So this time we are investigating resistors in parallel. So same setup as before, power supply, ammeter to measure the current coming in and out of the power supply, voltmeter across the power supply to see what it's actually giving out. So at first stage we stick the resistor in and it's just like before, and we use the V equals I times R or R equals V over I calculation to work out what's going on there, and that's fine. This time, every time we add another resistor identical to the previous one in parallel, we are giving the circuit more routes, paths or options. What that means is every time you add a resistor in parallel, the whole circuit gets very slightly easier. So when there's only one path, or the current has only one route to take, so that's a harder circuit. But when there's a second resistor, there's two paths, so the whole circuit has got slightly easier, so the total resistance will be less. When there's three different routes to take, the whole circuit has got even easier still, and therefore the total resistance of the circuit must be less than any of the individual resistors that were there on their own. Remember, all the current is coming out and going back into the cell. It's at these points where the current splits up. So once again, use the FET circuit builder to run this, get a set of results, record it in a similar table as before, and a graph of your results. Okay, enjoy. Okay, so a quick reminder how to use the FET circuit builder. Make sure you use lab mode, it's much easier. Drag your power supply in. Feel free to tap on it and change the values. You don't have to just use the default ones. Make sure the ammeter is coming so it's only measuring the current in and out of the cell or battery, not what happens down an individual path or branch. That's coming another time. Drag your resistors in again. Feel free to change the values, but make sure they're identical. I'm setting up the circuit sort of like this so I can quickly get a set of results. So there's just one resistor, note the voltage and the current. And then I can actually build in these paths ready, though not connected them yet. And then as I connect them up, notice that doesn't change, but look what happens to the current, the rate of flow of charge. And as you can see, it's suddenly increased because now you've got two paths, so the whole circuit's got easier for electrical current to flow around it. And then you can add a component at a time, remembering to record your PD and current every time. Obviously PD is not changing, and then also your number of resistors. Fill out your table as before, and there's your set of results.